Hi everyone, we are here to talk about scatterplots and correlation. So get the note packet from the sub and follow along. We're going to start with scatterplots, correlation, and line of best fit notes, and then you're going to do some multiple choice practice. All right, so we're going to get started by talking about independent versus dependent variables. We've talked a lot about this already, but remember the independent variable is the variable that you control. That's your x variable, right? That's always going to go on your x-axis. And your dependent variable changes depending upon what happens with your independent variable. And that's always going to go on your y-axis, right? So just to look at like some quick examples, in each of these situations, we're going to determine which is the dependent and which is the independent variable. So number one, if researchers are studying a new cold medicine, give different amounts of their medicine to mice and then record each mouse's body temperature. So the two variables are going to be the different amounts of their medicine that they give and then the mouse's body temperature. So think about which one's independent and which one's dependent. Which one depends on the other? So the body temperature is going to be dependent on the amount of medicine that they're given. So this one's independent. And because of that, this is your X and then this is your Y. All right? Read number 2 and try this one. So your math teacher looks at your grade on Schoology and asks how much time you spent studying for the last unit test. So think about it. What are your two variables? Which one's independent? Which one's dependent? So how much time you spent studying is one variable, and also your grade on Schoology is another variable, right? And the amount of time that you spent studying, that's what you control. And then your grade on Schoology depends on the amount of time that you spent studying. So this is your Y variable, and this over here, the time you spent studying, is your X variable. Number 3, if you make a graph of your height at different years throughout your life, think about what are the variables and which one's independent and which one's dependent. So your variables are height and the different years throughout your life. Your height depends on your age, right? And so your age is your X variable and your height is your Y variable. I just realized I spelled this wrong. Dependent. Right? All right. So now let's talk about what a scatterplot is. Hopefully this will be a little bit of review for you. A scatterplot is a graph that relates two groups of data. So the two groups of data are come from your independent and your dependent variable. And like we just reviewed, the dependent variable goes on the y-axis, that's over here, and the independent variable goes on the x-axis down here, right? Because we have like x and y. And so if we look at people's weights versus their heights, each of these dots here represents one person. So this person here, this might be me. This is my weight and my height. So if I count how many dots there are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 dots, that means this gives me data on 11 different people. All right, so that's a scatter plot. So now let's talk about correlation, what we call correlation. If a correlation is linear, then the pattern of the data follows a straight line. So in other words, when we look at scatter plots, we're looking for the pattern of the data. And we're saying, where does the pattern, or what does the pattern follow? Does it follow a straight line, a curved line, something else, whatever? So the question is, which of the correlations in these scatter plots is linear? So if I look at letter A, let's start with letter A. Let's look at the pattern. I always like to draw kind of a line through like the center of the points. And every point does not follow that line, but that line is kind of in the center or the middle of the points. And that line is linear. So we're going to say that this scatter plot has a linear correlation. If I look at B, again, draw a line through the center of the points. Like, where does the pattern go? So the points go kind of in that like U-shaped pattern. And that is not a straight line, so we're going to call that nonlinear. Again, letter C, if I draw a line through the center of the points, it kind of has that curved shape, so it's nonlinear. And then in D, again, find like where's the middle of the points? Where's the pattern going? It's kind of going up like that. And again, it's nonlinear. So the only one here that's linear is letter A. So now that we know what linear correlation is, let's talk about different types of linear correlation. So if you look at all of these different scatter plots, you're going to notice some of them are kind of like closer together. Some of the points are closer together than others. And if the points are closer together, then the pattern is strong. And also some of the points are going in a positive direction. Remember we talked about like slopes, right? Any slope that goes like this has a positive slope. Or I should say, any line that goes like that up from left to right has a positive slope, and any line that goes down from left to right has a negative slope, right? And so the same is going to be true with correlation. So whenever you talk about correlation, you're going to have three words: the direction, the strength, and whether it's linear or not. So if I look at this first one here, again, draw my line through like the center of the pattern. Kind of goes like that, right? From left to right, this is going in a positive direction. So this is a positive, and those points are pretty close to that line. They're not exactly on the line, but they're pretty close. So we're going to say it's strong, and it's also linear. So that first one has a positive, strong, linear correlation. If I look at the second graph looks like, if I want to find kind of the middle of the points, it kind of goes like that, right? So again, the line that I just drew has a positive slope. Whoops. But the points are a little bit further away from that line. So we're going to say it has a positive moderate, but those points still follow like a straight line pattern. So it's linear correlation. And then if I look at the one in the middle, kind of like, what's the pattern? Do the points go up? Do they go down? Do they go straight across? Which line is best? It's really hard to tell. You can't really tell. So we say that this has weak, or you could say no correlation, because it doesn't really have a pattern. They're all kind of just like jumbled together. And then this fourth one, if I draw the line through the middle, you can probably guess, but the line has a negative slope. So it's negative, moderate, linear, because the pattern is like a straight line. And then the last one here, if I draw the line Again, it's negative, but this time it's strong. The points are close to the line. Linear correlation. So again, whenever I talk about linear or talk about correlation, I need to talk about the direction, the strength, and whether or not it's linear, right? So 3 words. Okay, so now you're going to do some practice. So you can pause here, try your practice problems on your paper, and then you can unpause and check your answers. All right, so this first one, let's talk about this first one. I would say this first one, kind of the points do follow a straight line. So I would say it's linear. It's positive because the line is going from left to right upwards. Make sense? So it's linear, it's positive, but I would say it's a moderate because some of the points are not so close to that line. And then the second one, if I look at the second one, the pattern kind of goes like this, and then it kind of starts to curve at the end. So this probably is a nonlinear, but it still has a negative slope to it. From left to right, it's going down. And I would say it's a pretty strong correlation. The third one, the points are kind of all over the place. Like think of it as like a big blob. So we say that there's weak or no correlation. Remember, correlation is like the pattern. There's really no pattern. And then the last one, if I look, it definitely makes this kind of like curved shape. So I would say that there's a really strong negative, but it's non-linear. Because those points are really close to that line that I just drew, so that's what makes it strong. All right, now let's talk about what we call the line of best fit. A line of best fit is a straight line that best represents the data on a scatter plot. The line should have approximately half of the data points above it and half below it. So here's 2 examples. Example 1 has a negative linear correlation. Because again, if I move from left to right along this line, here, let me use a different color. You could see it a little better. But if I move from left to right along this line, so from left to right, the line's going down, right? So it has a negative linear correlation. That line that we've kind of been drawing through the middle of the points, that's what we call our line of best fit. And at number 2, from left to right, my line is going up in a positive direction, so it's a positive linear correlation, right? All right. So which graph has the line of best fit, the one on the left or the one on the right? If you look closely, the blue points in both graphs are the same. These are both the same scatter plots, but what's the line of best fit? What's the line that goes through the middle of the points? Hopefully you can tell it's this one here. The question is, what's wrong with the other graph? Now, let's focus on the line itself, the red line itself. Every line has like a y equals mx plus b, right? It has a slope and it has a y-intercept. So if I look at this line over here on the left, is the slope correct? Should the slope of the line of best fit be going up from left to right like this? No. So hopefully you can see that the slope is wrong. It should be negative. So that's the first part. The slope should be negative, right? And then the other part is the y-intercept. If I look, I can't really see the y-intercept here, but if I like extend this, this is 0, this will be like 1, 2, this might be 3. So -1, -2, -3. So the y-intercept here is about -3, which it shouldn't be that. It should be like way up here, right? The y-intercept should be up at like 18 or so. So the y-intercept is way too low. So those are the two problems with this line over here on the left. And you can see they're kind of fixed over here on the right. All right, let's do some multiple choice practice. So I'll give you a couple problems and you can just kind of pause the video as you go and then we'll talk about them. So which shows the line of best fit? So again, all four graphs are the same. The scatter plots are the same. The lines are different. So which one is the line of best fit? Which one's the line that goes through the middle of all the points? Hopefully you can tell it was letter C. Letter A, the slope is positive. It should be negative. Letter D, the slope here is 0 because it's like a horizontal line, right? It should be negative. Letter B, the slope looks good, but the y-intercept is too high. It doesn't really go through the center of the points. All right, again, which one's the line of best fit? So hopefully you can tell that letter A is definitely out. That line doesn't go through the points really or follow the pattern at all. The other three all have negative slopes, which is good, but it's kind of like which negative slope is the best. If I look at D, the line goes through some points, but doesn't really follow the pattern of all the points. Not really. It doesn't really have like half of the points above and half below. It doesn't go through like the middle of the points. And the same with C. It has 2 points on the line, but then all the other points are above it. So hopefully you could tell B should be the line of best fit. All right, how about this one? So take a minute, read it. So what kind of relationship between class study time and test scores is shown? If I look carefully, the pattern, the line that I would draw is going up from left to right. So it would be a positive correlation. And then here's another one. Miss Esposito recorded the age and shoe size of each student. The graph is her data. Which of the following correlations is displayed? So when I look at this, I see these points that are kind of like all over the place. They're like just all scattered. So that tells me that there's really no correlation. It's not positive, it's not negative. All right, try this one. So the scatter plot shows the average traffic volume and the average vehicle speed on a certain freeway for 50 days in 2010. Which statement best describes the relationship between average traffic volume and average vehicle speed? So if you look at your answer choices, it talks about as traffic volume increases, what happens to the vehicle speed. So kind of look at the slope or at the pattern. If I look, and this might even be a little, you could say it's like a little curved. But as traffic volume increases, so as I go from left to right, like this direction, what's happening to the average vehicle speed? Is it going up or is it going down? Or is it going up and then down? That's letter C, up and then down. Or is it going down and then up? Even though it curves a little bit, it's never really increasing. So the correct answer would be B. And then that's it. Thanks for watching. Have a great day.